Welcome back, everybody. This is problem 3 from Quiz 1, Spring 2023, Math 302. And we're moving on to the section on relations and functions here. So we start with two sets. Let's see, S and T. And let's see, S is given as a set with 4 elements, W, X, Y, and Z, whereas T is given, well, also a set with 4 elements, but they're 3, 5, 7, and 9. We want to determine whether each of the following sets, oh wow, look at this, down below we have sets, is a relation from S to T, or a function from S to T, or an injection from S to T, or a surjection from S to T, or a bijection from S to T, or none of the above. Okay, oh, how nice. We don't have to explain our work, so we just have to write down letters. Beautiful. Okay, well, let's make sure we know what these things mean here. So let's see, first, a relation. A relation from S to T, what should that be? So a relation from S to T, that is just going to be a subset. All right, so I'll use like a curly R here. It should be a subset of the Cartesian product of S and T. So remember, the Cartesian product is going to be pairs of elements, where S is in big S and T is in big T. Okay, so let's see, does this work? Is a relation from S to T? Is it a subset of S cross T? Well, let's see. W comma 3. That is certainly something that has something from S comma something from T. X comma 3. Y comma 3. Yeah, absolutely, right? This is definitely a subset. So I can put R here. Let's look at the next one. W3, that's the same thing. And look, W3 on all of these, right? That's definitely an S cross T. X comma 2. Oh, this 2, look at that. The 2 is a problem because there is no 2 in T. So this is not a subset of S cross T. This is the problem. Okay, so we don't get to write R here. Let's see, the next one. W3, X5, Y5, Z7. Yeah, they are all in there. Okay, so this is a relation. X5 to Y9, Z7. Yep, definitely a relation. W3, X5, Y7, Z9, W9. Oh, look, now W showed up twice. Is that a problem? Not for being a relation. It just needs to be a subset. And yeah, everything in here looks like something in S, comma something in T. So this is, again, a relation. Okay, so next we had functions. So what's the difference between a function and a relation? So a function from S to T. All right. Well, let me call it little f for function, right? Well, this also has to be a relation. So it is also a subset of S cross T, but it has to have an extra condition. Actually, two extra conditions. Okay, so first, we know that every element of S has an F image. Okay, so what do I mean by that? I mean there is something of the form, if I have little s in S, so for S in S, there exists a T in T such that little s, little t is an element of F. Okay, the second condition is that every element of S has only one F image. Okay, well, we could really put these together into one, right? So there's at least one F image, but there's only one F image. Okay, so the way we can combine this is by just putting an exclamation mark here. This means there exists a unique T in T such that ST is an F. Okay, so we really combine these into one. So being a function means you're a relation for which every element of the domain has exactly one image. Okay, so let's check that. All of these, oh, except for this one wasn't a relation, in fact, which means it's not going to be a function. And we don't even talk about injective, surjective, or bijective when it's not a relation. So this definitely we just say is n, right? That's all we're going to get. But for A, C, D, and E, we got to check. So do we have exactly one image for every element in S? So W, sure, we have a 3. X, yep, 3. Y, 3. Z, oh, no 3. So we do not get function here. Now you might say, well, wait, didn't we have 3 used already? Are we allowed to use 3 again? And the answer is yes, because when we say for S in S there exists a unique T, we're just saying you pick an input, there is some output, right? Exactly 1, in fact. It says nothing about what happens when you look at 2 different inputs, right? That's just not going to be an issue for functions. We'll see that when we talk about injections. Okay, so we don't get a function for this first one. This second one is none of the above anyway. The third one, let's see. W has a 3, X a 5, Y a 5, Z a 7. Yep, we're good. We have a function. D, W3, X5, Y9, Z7. Yep, everything goes to exactly one place. It's again a function. Okay, W3, X5, Y7, Z9, W9. And here we have a problem because W has 2 different images, 3 and 9. We're not allowed to have 2 different images, only 1. So we don't get a function here. Okay, we've handled relation and function. Now we need injection. So injection is what we might call a right to left condition. So injection from S to T. Instead of looking at elements of the domain and asking whether or not they have unique images, we're looking at now elements of the codomain. Okay, so we're looking at things in T, and we're asking whether they have a unique pre-image. Okay, so this would mean every element of T, well, actually not every element of T. Okay, because some elements of T can have no pre-images, and that's okay too. So we'll say every element of T, but then we'll change what how we finish. Every element of T has at most 1 F pre-image. Okay, so it could have 0 pre-images. That's fine. Okay, so let's check. 3 has W as a pre-image. It also has X as a pre-image. So this is not injective, right? We have, if is basically we just look, does a number show up more than once in the second component? Okay, we can skip B, 3, 5, 5, oop, we see 5 shows up twice, so that's not injective. 3, 5, 9, 7, no number shows up twice, this is injective. Okay, 3, 5, 7, 9, 9. 9 shows up twice, so we're not injective. Okay, so actually only one of these was injective. Okay, next was surjective. So a surjection from S to T. What did this mean? This means that every element of T has at least 1 pre-image. Okay, so I go back up to T. I got to remember, what do I have? Yes, 3, 5, 7, 9. That means 3, 5, 7, 9 all have to show up as a second component. Well, this first one, 5 doesn't show up, neither does 7, neither does 9. None of them have pre-images, so this is not surjective. Okay, we get to skip B. 3, 5, 5, 7. Am I missing any? Yeah, I'm missing 9. 9 doesn't have a pre-image, so this one is not surjective. 3, 5, 9, 7. Okay, yeah, we hit everything. Everything got hit at least once, so this one is surjective. And then 3, 5, 7, 9, 9. Yep, again, everything got hit at least once. Yeah, 9 shows up twice. That's okay. So this is also a surjective relation. Okay, finally we have bijection. And bijection is just injective and surjective. Or if you like, every element of T, well, let's see. To be injective, you have to have at most 1 pre-image. And to be surjective, you have to have at least 1 pre-image. Well, if you need both of those, at least 1 and at most 1, that means you have exactly 1. So every element of T has exactly one F preimage, where F here would be the function, right? I keep saying F like we've written it down. Okay, so which of these is injective and surjective? Well, only D. D is both I and S. So we just could have put a B there. Okay, so there we go. Um, now, there's another problem, right? If we look at this, an answer might look like RFIB. That should look a little funny to you. Okay, so this is actually problem 4. So we'll scroll down and put it in here. Explain why the sample answer I gave above, RFIB, is nonsense. All right, so this would be a relation that is a function which is injective and which is bijective. And notice here I'm missing a letter, right? I'm missing surjective. So why is this nonsense? Well, this is nonsense because every bijection is a surjection. So I cannot possibly write B without also writing S. Okay, so there we go. All right, well, we got one more problem on this quiz. That'll be problem 5. We'll see you next time.